understand the history of that ice. And in addition, we want to know the active processes that are allowing the ice to sublimate into the atmosphere, creating water vapor in the atmosphere. And we want to understand how the atmosphere can also freeze out into the soil. Finally, because this ice has the potential of melting as Mars goes through climate changes, it's a possibility that this is a habitat for Martian organisms. And we are hoping to be able to understand the properties of this habitat, whether the water has been liquid, whether there's energy sources that would allow microorganisms to survive, and whether there's in fact organic molecules associated with this layer of a complex enough nature that there might have been life in the past or even current life.
What are some of the instruments Phoenix will be using to help accomplish the mission?
First, we have cameras. And then, besides looking at the environment, we're going to interact with it with a robotic arm. And we can dig down as much as 3 feet. And probably we can't get that deep because the ice is very hard. And so we're probably just going to get down to a hard ice layer and then scrape off samples. And as we collect samples of both soil and icy soil and ice, we will deliver them to 2 instruments on the deck of our spacecraft. And there we'll do a chemical analysis of the soil samples to try and accomplish our science goals.
Didn't the Viking landers in the 1970s dig as well? Why would we need to do that again?
Well, the Viking mission in 1976 had an arm also, but it basically had a little sample collector, and it was able to collect samples from the surface. They actually moved rocks and got samples from under rocks, but they did not have the capability to dig down 2 or 3 feet like our mission will do, and they did not have an ice layer underneath that would change the soil as it melts. So hopefully we start with what they learned on the very top surface. We expect to see something very much like what Vikings saw, and then we move into an unknown realm as we get near the ice layer.
Like its namesake, the Phoenix lander rises from remnants of its predecessors. Phoenix will use many components of a spacecraft originally built for the canceled 2001 Mars lander mission, and will also include improved versions of other instruments flown on the lost Mars Polar Lander. Because many of these instruments have already been validated, the cost and turnaround time for Phoenix is relatively short. Once on the ground, the instruments used on Phoenix will analyze the soil and atmosphere, then send that information back to Earth via a relay through NASA's Mars Reconnaissance Orbiter, as well as the Mars Odyssey and Global Surveyor orbiters. NASA planners believe that this low-cost option will reap huge dividends in the form of scientific knowledge.
It is a lot of money. I think everybody knows that. However, we do not send the money out into space. The actual value of the physical things that go out there is very small. The money is spent within our aerospace industry, at our NASA centers, and at our universities. And it goes to develop an expertise in our country for understanding how to explore planets, how to design the most advanced communication and propulsion systems, how to engage the public in interesting exploration missions. The money goes for very wonderful, peaceful purposes. And I think this is the age of exploration, and it behooves us to go out and do it. We expect it's going to be one mission after another, each building on the discoveries of the last, and that's how we're going to understand our neighbor.
One tool that will be invaluable on any mission into space is a spacesuit. Whether floating around the International Space Station or walking on the Moon or Mars, spacesuits will be used to keep our astronaut crews safe. Here is Johnny Alonso to find out how they work.
Space is an incredibly brutal environment. Not only is there no atmospheric pressure or oxygen to sustain life, but human explorers must also deal with intense radiation and extreme temperatures in order to perform even the most basic tasks. Inside a spacecraft, the atmosphere can be controlled so that special clothing isn't needed. But when outside, humans need the protection of a spacesuit. In 1961, astronaut Alan Shepard wore one of the first suits designed for spaceflight aboard the Freedom 7 spacecraft. This suit was actually a modified version of a Navy high-altitude jet aircraft pressure suit. Spacesuits have come a long way since then. The current Extravehicular Mobility Unit, or EMU, is the result of many years of research and development, and is also a powerful tool for operations outside the International Space Station and the shuttle. Now, I spoke with engineer Phil West to find out how it works.
Most people have this preconceived idea that a spacesuit is pretty simple, heavy cloth and things, but it's really a mini spacecraft that lets you step out into this very harsh environment.
What are the consequences of not wearing a spacesuit?
Well, it's a bad day if you don't wear your spacesuit. First of all, there's a vacuum in space, right? So just like when you open a soda bottle, it's gonna fizz, right?
Sure.
Your body will do the same thing. And literally what's happening is your body fluids, your blood, and everything are gonna boil, all right? And it's not because of temperature, it's because of pressure. Remove the pressure and whoosh, that stuff wants to come out. So then you've got temperature extremes. I don't mean temperature of space. You need molecules to have temperature, but your temperature, the spacecraft's temperature, could get very cold or very hot depending on whether you're in the sun or in the shade or the things around you.
Sure.
Okay, and then there's little particles of natural or human-made stuff that fly around space at high speeds and could literally
Space debris.
hit you, yeah. Or micrometeoroids, natural stuff that comes in from elsewhere.
What are modern spacesuits made out of?
Think of the spacesuit as a balloon shaped like your body.
Okay.
All right, and we've got to have a layer to make that balloon. So we use this urethane-coated nylon. Okay, that's like camping tent material, but it's got a coating on it to seal it up, and that's the basic layer that holds all the gas in. We put that and we make it the shape of your body. We call it the bladder. Now, what would happen to a balloon if you inflated it too much?
And it'll pop.
Right, pop, which is bad. So in a spacesuit world anyway.
Right.
So we got to constrain it. We got to make sure it's the right shape. So we use this polyester layer to give it structure and strength and make sure it's the right shape of your body, the right size, arm length, etc. So that's the first two key layers of the spacesuit. Then remember temperature extremes we talked about?
Yes.
Okay, we have 5 layers of aluminized mylar. So now think of the spacesuit as a thermos bottle. You know how a thermos bottle works? It's got a vacuum between an insulator and a glass jar with a silvery coating on it. So that's for thermal protection, and then a real tough layer of
What's this?
Nomex with Teflon coating on it. Feel that's kind of slick, right?
Yeah.
And it's got Kevlar woven into it, a very strong fiber.
Okay.
And that's so you don't get tears and you protect all these other layers very well, right? You don't want to get a hole in here because you don't want to get a hole back here in your
You
bladder.
don't, right. Phil, how do these spacesuits operate?
Well, you've got a control pack on the front and a life support system on the back, all right? And that life support system is more than just oxygen. It's got batteries for power, a radio for communications, computer, and a bunch of plumbing and things to keep you alive.
Okay.
And that's all controlled up in the front here with this control pack. And so we've got some places for the astronaut control, like their communications equipment. You can open that valve if your suit overpressurizes. There's a little dial there to change your communications mode, and a little display to tell you, hey, you know, Johnny, you've only got 3% battery power left.
Time to go
Pack up
back.
your toys and bring it on in. And then controls in the front here for volume and your position, whether you're inside or outside the spacecraft, is up here on the front.
And what's this dial?
Well, that's for temperature. Remember, we're inside a thermos bottle, okay? And you're a heat engine. You're actually producing heat. You're not just like hot chocolate.
Okay.
Hot chocolate in a thermos bottle stays warm, but it doesn't get any hotter. You would get hotter, right? You'd overheat. Literally, your own body heat would be your downfall because your body heat is going to have nowhere to go. It's going to be trapped in there with you.
Right.
That's what happens in a spacesuit. So literally, what we'll do is pump cold water all over your body through long underwear like this.
Check that out.
All right? And so that is plumbed. This connects inside the suit, and then this dial controls the temperature of the water that flows over your body through all these tubes. There's enough tube in there to stretch the length of a football field.
Really?
And you can actually see the water. See the air bubbles in there? There's a few air bubbles.
sure,
It's all charged right now.
So Phil, off the record,
Yeah.
how do you relieve yourself in one of these?
Good question. You know, well, you've got a drink bag, so you're going to want to drink some water, and eventually that's got a place to go. Well, it's pretty technical. It's a diaper.
Lovely.
The whole idea was, let's save money, let's use adult off-the-shelf diapers. We sew extra material into them. They work great if you can get past the idea that your mom told you not to go in your pants.
Hey Phil, thanks a lot. You know,
Yeah.
giving us all the info about spacesuits.
Sure.
Listen, I was wondering, can I get like a souvenir off this?
Oh man, I wish I could, but there's no
So
way. You know, it's
cool.
pretty nice stuff. We really can't wait. Let me think. Well, you know what? Actually, we don't. This is used. We don't need the diaper anymore. You can have that.
That's all for this edition of NASA's Destination Tomorrow. Thanks for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.